Okay guys, these are the solutions for the potential M1 paper. So the question one is quite easy. I did it in column vectors, but you could do it normally, that's fine. So I just use I equals R0 plus Vt to get the vector, and then I just sub in t equals to 10. Question 2, I actually have done it in quite detail, so I drew a diagram for each individual section. So to get the minimum P, you just put the friction towards upwards direction, and then you write your forces as shown, and then solve it. And then to get the maximum value of P, you put the friction towards downwards direction, and then you solve it again. Okay, so you can pause it and read through the steps if you want. And then part 2, so now the P is given as 150 newtons. The object is accelerating upwards. You just again do the equations and solve it. You obviously have to work out the mass, which is 5 kg, and the acceleration turned out to be 14.03 meters per second squared. Question 3. So what I did, I worked out tension first of all, and then, I worked out acceleration first, and then I worked out the tension. So the first exerted on pulley is 2 tensions as shown, because there are 2 downwards tensions as well as the upwards tensions for the 2 particles. Part 2. So I worked out the velocity before impact first of all, and then after impact, so that velocity before impact would become the initial impact for the movement under soil, and then I just put final velocity as 0, s as 0.03 because it's obviously centimeters, and then I worked it out. So I put acceleration as g over 4, and then I worked it out. Okay, and question 4. Well, first of all, part 3, for B after impact. So initial velocity is actually this question I was talking about before. So the initial velocity is 3.5 meters per second, final velocity is 0, acceleration is a question mark, 3 centimeters is the distance, which is 0.03 meters, and when you plug it in, you get minus 204.17 meters per second squared acceleration. So the force exerted would be mass times that, which is 1021 newtons. Okay, question 4. Question 4 has a little mistake, guys. The distance between A and B is 1 meter, and distance between B and C is 1 meter. So you would need that to calculate the question. So if you haven't done that, then I would say go back to the question and then work it out. So first of all, it's quite easy to get the first one. The velocity after collision from the combined objects were 5 meters per second. So to get part 2, you need to first of all work out the speed before the second collision. That wouldn't be the 5 meters per second because there's friction on the ground between B and C. So BC is 1 meter. So this is what I haven't written in the question. So if you want to redo that, that's up to you. So it would hit the third object at 3.21 meters per second. So what I did is I draw a separate diagram here. So the combined object is 7 kg. It's going to hit this object with 3.21. So the combined triple object after collision is 2.04 meters per second. And then after the second collision, you've got to work out the acceleration, and then from the acceleration you could work out the distance it would travel before coming to rest. So the total distance traveled by A will be 1 meter between A and B plus 1 meter between B and C plus 0.284 meters after second collision, which is 2.284 meters. Okay. Question 5 is probably one of the easiest in the paper. So you just resolve forces vertically and horizontally, and you get the time equal to 3.47 seconds. Well, you resolve the forces to get the acceleration, which is g sine 25, and then you work out the time from there. Question 2. So now there's a force F going upwards. Horizontal, it says horizontal, so that doesn't mean horizontal to the plane, it's just horizontal to the ground. Okay, so R equals to 10g cos alpha plus F sine alpha for the reaction, and horizontal to the plane will be 10 times 2 acceleration, F cos alpha minus 10g sine alpha. So basically from that you can work out F equals to 67.8, and also R equals to 117.5 newtons. Okay, so that's question 5. And question 6, so quite easy to get R using moments about A, which is 91.9. And then question B, you put the boy somewhere there, and then first of all you work out RC using 3.5 times RC is RA, you get RC equals to 24. And then you take moments about A and you get AD equals 2.6. And question C is quite straightforward really. RA equals to 0, so RC equals to 15G plus 45G, which is 60G, so it's 588 newtons. Okay, so I'll leave it there, guys. If there's any question, just ask. I'll try to answer to the best of my ability.